video I'll be doing problem 57. 57 reads, the two pendulums shown in figure E14.57 each consist of a uniform solid ball of mass m supported by a rigid, massless rod, but the ball for pendulum A is very tiny, while the ball for pendulum B is much larger. Find the period of each pendulum for small displacements. Which ball takes longer to complete a swing? So we want to find the period of each ball. So ball A, since it's a small point mass with small displacements, for the period equation, we use omega equals root g over L. So we have period equals 2 pi over root g over L, and it'll just end up, you just flip this over on the top, the L and G, flip that over and put it on top, and it'll just end up being the period equals 2 pi root L over G for ball A. And then for ball B, we do the same thing with this period, 2 pi over omega, but for omega, since it's a large mass, we want to use omega equals root mgd over I, over moment of inertia. And so it'll be t equals 2 pi over root mgd over moment of inertia, and we do the same thing and we flip it. So then ball B will be 2 pi times root moment of inertia over mgd. But we want to put this in like terms as ball A. We want it to be some kind of L over G. So we have to use moment of inertia. We have to figure out its moment of inertia. So for a sphere of so for this sphere, a sphere's moment of inertia is 2 pi mr squared, and we want to add md squared for the total moment of inertia. So the radius for this sphere, as shown in the figure, is r equals L over 2. And d is just L. So then we'll have the moment of inertia equals 2/5 m L over 2 squared plus m L squared. So then this will become L squared over 4, and we multiply this by 2 over 5. So then we can simplify this, cancel these two numbers out, make this 1, make this a 2, so it'll be L squared over 10 for this first part. So we'll have mL squared over 10 plus mL squared. So then we just add these two terms and we get 11 over 10 mL squared for that. So then what we want to do, we want to plug that into here, and we also plug in L here for the distance. So let's take this part away. So we have t equals 2 pi times the square root of 11 over 10 mL squared over mgl. So then we cancel out these two masses, and then we cancel out this L on the bottom. So then we're left with t equals 2 pi square root of 11 over 10 L over G for ball B. So we can see that ball B has a slightly larger period because of this 11 over 10. So we can therefore conclude that ball B will take longer to complete a swing. And that is problem 57.